All right, good day, everyone. Today we're going to be talking about Descartes' rule of signs. Please note that this lesson in particular is just kind of another testing value. Like we've talked about before, a lot of these lessons have to deal with like what would happen if you didn't have a calculator and you had to solve these out. This is basically one of the possibilities that we could use to basically help us actually solve out some of this information. Okay, so note that this really isn't a how should I describe it? This isn't really an analytic thing. This is more of a testing thing. Okay. I'm not trying to get specific answers. I'm trying to test and see how many of those specific answers I could have. Okay. So a lot of it's dealing with like possibilities. All right. A lot of the reasons we do this is because logically, if we get all these different possible outcomes, then we can combine them all together and come up with like a logical based answer for what the graph's going to look like. Okay. So here's how this basically works. We're basically going to be testing for both positive and negative real zeros. Okay, basically that means is we want to test and see how many negative x-intercepts we're going to have, how many positive x-intercepts we're going to have. Okay. Once again, if you're thinking about what we did yesterday with like p's over q's and everything, this could be very useful when it comes to just testing values. Okay, if I know there's supposed to be two positives and one negative, I'm going to go ahead and test the positive values out and see if I can simplify that equation and then use those positive values to my advantage. Okay. Or for another example, like let's say you're using the factor theorem. If I knew there was only one negative zero, once I find that negative value, I don't have to keep testing all those over and over again. I found the one specific one that matters. Okay. Now, once again, this is kind of a purpose to speed things up. However, it's not always needed. Okay. I'll be the first one to say that this is kind of a situation where you don't necessarily need to use Descartes' rule of signs. You don't need to actually like hold it into every single one of your problems. It's just kind of like having another tool to use just in case. So let's go ahead and just talk about this. So how this works is we have to be able to determine the number of positive and negative real zeros. Okay. So the idea is that I want to basically take each of these and determine how many possible sign changes we have. Okay. Those sign changes will describe to me how many possible zeros we have. So we're always going to test two different values, the positive and the negative. For positive real zeros, I'm just going to look at my original equation of h of x and determine how many sign changes there were. Okay. For negative, I'm going to do the same thing, but I'm going to plug in a negative x for all my values, kind of like how we did for odd and even functions. And I'm going to determine the number of sign changes. And then the key thing you want to understand is we always go by even integers. And we'll talk about that when we actually get to that value. Okay? We're always going to look at even integers. Oops. Let's fix my spelling here. And then same thing for the odd functions. We're still going to always have even integers. And we'll talk about why that is once we get to our final answer, okay? But let's go ahead and look at this first one. So let's start off by looking at positive sign changes, or how many positive real zeros we're going to have, okay? So the focus here is how many possible sign changes do you have from the starting point down the line, okay? Well, if you notice this, I want to look at the actual value in front. So if you think about the x cubed here, that's a positive x cubed. Versus if I go into my next term here, we have a negative 4x squared. So you notice how we go from a positive to a negative? So I have a clear sign change from the cubed to the squared. Well, same thing. Now I go down the line, we have a sign change from the negative back to the positive. It went from negative 4x squared to a positive x. So if you notice, you have two sign changes, x cubed to the 4x squared, and then 4x squared to the positive x. After that, if you notice, between the x and the positive 5, there isn't a sign change. It went from positive x to positive 5. So in this case, I had two sign changes. Okay? What this tells me is I have a possible two real zeros going through the x-axis, or I have a possible 2 positive x-intercepts. Okay, so what this tells us is we have 2 or 0 possible x-intercepts. Okay, and the whole idea is that I always want to do it in integers of 2. Okay, so if I had 4 sign changes, I would have a possible of 4, 2, or 0 possible x-intercepts. Okay, once again, since this is a testing value, we always have to keep in the idea that sometimes you don't get real zeros, you get imaginary ones. So what this is basically telling me is that we could have 2 possible zeros. Or in case they are imaginary, we could have 2 imaginary zeros. Okay? That's kind of the idea here. So that's the first portion. That's how many positive x-intercepts I could have in this function. Well, now let's do the same thing, but with negative. And when we find negative, all we have to do is plug in that negative x into my equation. So let's see what happens if I do that. I would plug the negative x in. This would be negative x cubed minus 4 times negative x squared minus x plus 5. Well, if I simplify this, x cubed is going to stay negative x cubed. Negative 4x squared, well, in this case, the negative x and the squared are going to cancel the negative out, or I should say the squared is going to cancel the negative out. So this would stay as negative 4x squared minus x plus 5. Okay? So in this case, when I look at this, we only really have one true sign change, because if you notice, it stays negative, 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 and then becomes a positive right here. So because of that, I have one possible real zero. Okay? Or I should say one negative real zero. Okay? Honestly, let's rephrase this to negative real zero. Okay? Just like how this one now tells us how many positive real zeros I could have, this one down here is telling me how many negative real zeros I could have. Okay? So now when I think about this problem in the actual degrees itself, I can use this information to my advantage. Okay? So if we just think about this, this is a degree 3 polynomial, right? So I'm thinking I should have 3 possible zeros, 3 possible x-intercepts. Well, by using Descartes' rule of signs, I can basically assume now 2 of them could be positive and 1 of them could be negative. So now when I'm actually testing my values out, I don't want to be testing so many different negative values. Once I find that one negative zero, I should go and turn off all the other negative possibilities and just focus on the positive ones. So you see how this can kind of break down even more how many possible zeros you could have. Okay? It's not necessarily about like telling us exactly the answer. It's about telling us what we're actually going to test. Now, like I said, this particular lesson is not necessarily like a full-on like this is your particular answer. Use this problem to simplify everything. No, because it's not really how it works. Okay? This is more of another opportunity to help us simplify what we actually have to test. So when we start doing those P's over Q's and we get 12 different possible terms, we know that we should be testing more of the positive versions, or we should be testing more of the negative versions for their answer. Okay? Besides that, that's today's lesson. We'll go over this in class tomorrow and kind of go in deeper meaning of this and even talk about how we can use this in the full graphing type problems. Okay? Besides that, make sure you watch the whole video, and I will see you tomorrow in class. Have a great day.